This is problem number 7 on the practice problems for test number 3. Consider the power series summation n over 4 to the n x to the n. Part A, write out the first 4 terms of the series. So all we do is plug in the first value of n that we see, n equals 1 in this case, 1 over 4 to the 1 times x to the 1. The first 4 terms technically is a list of things, so I'm not going to put a plus sign, I'll put a comma, but I'll accept a plus sign. Now n is equal to 2, so we get 2 over 4 squared times x to the 2. You can reduce that. Next one, when n is 3, 3 over 4 cubed, x to the 3, and then finally 4 over 4 to the 4th, x to the 4. So those are the first 4 terms of the series. It sure looks like these terms are going to head to 0. That exponential in the bottom is going to dominate the n sitting upstairs. I say the series goes to 0, the terms go to 0. I meant to say the coefficients go to 0. I don't know what's happening with the x, but sure appears like these guys are going to 0. So let's find the interval of convergence. Whenever we have a power series, the ratio test is the right tool. So we're going to take a limit as n goes to infinity of the next term in the series divided by the current term, absolute value around the whole thing. So for the next term, we're just going back up to this thing here and replacing all the n's with n plus 1s. Don't forget to copy the limit over and over again. So let's do that. All the n's become n plus 1s. N plus 1 over 4 to the n plus 1 times x to the n plus 1. And then it should be, now we're doing the bottom part, divided by a sub n, and a sub n is just the entire thing as is. But let's just jump right to the part where we, instead of dividing by the fraction, multiply by the reciprocal. So 4 to the n goes upstairs, n goes downstairs. How about the x to the n? Where is it really in the original, this x to the n? Is it upstairs or downstairs? Well, it's really big is what it is. So what the x to the n is really upstairs. It's really up here. So when we flip it over, it really goes down underneath. So I will put the x to the n down here, x to the n. Absolute value, and now we're going to start to cancel, which is a big part of the ratio test problem. Still keep absolute value, and now we're going to reduce. So 4 to the n plus 1, 4 to the n, there's an extra 4 downstairs, extra 4 downstairs. X to the n plus 1, x to the n, there's an extra x upstairs. And then the n plus 1 and the n, I will just copy. N plus 1 is here, n is here. So that's what we get when we reduce. Next thing, as far as this limit is concerned, the variable is n, which means that x is a constant, and constants can come out front. Constant multiples can come out front of limits. Still in the absolute value, though. And then we'll copy the other parts here. So it's n plus 1 over 4n. Don't need absolute value anymore because everything there is positive. And I'm hoping we can do this limit without too much difficulty. Absolute value of x times. Here, the power upstairs is the same as the power downstairs. So in some sense, they cancel. Plus 1 makes no difference. And all we get is the coefficients. Coefficient is a 1 on top and a 4 on the bottom. So this limit is 1/4. And the ratio test always says that if you want to converge, you need that limit to be less than 1. And so then we just have to solve down here. The absolute value of x times 1/4 needs to be less than 1. All right, so how about we try to get that absolute value by itself. We'll multiply both sides by 4. Because it's a positive number that we just multiplied by, we don't need to flip the inequality. And then if absolute value of x is less than 4, it means that x is trapped between two numbers, -4 and +4. So this right here is the interval of convergence, except possibly for the endpoints, which we need to check separately. So the final interval of convergence may or may not include -4 and may or may not include 4, but that's all that we have left to do. So to check the endpoint separately, we'll go back to the original series. I'm going to copy that thing down here down below. This is where we do the endpoints, very typical for a power series calculation. So the original series, again, is n over 4 to the n times x to the n. And so let's go ahead and check the first endpoint. We'll plug in x equals 4. So the summation becomes n over 4 to the n, and now x is 4. So that becomes also 4 to the n, and then those 4 to the n's cancel. This happens pretty often when you're doing power series endpoint check. The 4 to the n's cancel in this case, and we just get the summation of n. So what can you say about that series? Well, if you're not sure, write out the first few terms. When n is 1, when n is 2, when n is 3, that is very much divergent. If you're really thorough, you can say it's divergent by the nth term test for divergence, which just says if the terms themselves don't go to 0, then the series automatically diverges. Let's try the other endpoint, x equals -4. Go back and plug x equals -4 into that purple summation right here at the top. Summation n over 4 to the n times, now x is -4, so it's that. And again, we've got cancellation, but in this case, yeah, the 4 to the n's cancel, but you still have that -1 to deal with. So I think what's happening here is you're going to have -1 to the n as a result of canceling these two things right here. You can check the details by maybe writing out a few terms, but I think what you'll see is that the terms are -1, +2, -3, +4, etc. And this one also diverges. Because again, the terms are not going to 0. So that's the nth term test. So putting it all together, I saw underlined up there in blue that the interval of convergence was -4 to 4. We checked the endpoints. This series diverged at both endpoints, so the interval of convergence truly is -4 to 4, not including either endpoint. Open on both sides.